Everybody, Mr. Adamson here. Today's lesson is going to talk about how we go about naming and identifying acids and bases. Now, naming acids that contain hydrogen. So there's a couple different ways here that we're going to be able to identify acids, and the first one starts with the whole idea of hydrogen. So the symbol for hydrogen is H, and hydrogen tends to appear on either the left or the right-hand side of a formula for acid. So if we look at the first example, HCl, we have hydrogen on the left-hand side of that formula, of that compound there, with chlorine. And that gives us hydrochloric acid. And the other way is the organic acid group, COOH. It has a hydrogen on the right-hand side, but specifically is combined with that organic acid group being COOH. And so if we look at the example of acetic acid, CH3COOH, and that is another way to identify an acid. Now, the third way to really notify if you have an acid or not is by specifically the subscript there of the solution that it's in after. Let me flip this up. We look. Oh, let me just go back. And we look right here at this AQ. AQ. That means aqueous. Now, aqueous, okay, is very important for identifying an acid because most acids are in an aqueous solution. So along with the hydrogens either being on the left or right-hand side, you'll have a solution, you'll have something in an aqueous solution. And that's another way to identify if you have an acid or not. Now, for the next one, you have naming acids that contain oxygen. Now, this follows a different naming system based on the name of the anion. So if the anion ends in 8, then the name of the acid that is derived from it is ic. So anion being the non-metal, probably the polyatomic ion. So if we look at H2SO4, now this contains the sulfate anion, so SO4 2-, an anion whose name ends in the suffix 8. And in this case, the acid's name begins with sulfur for the first element of the anion, and we ended in ic. So we would call that sulfuric acid. And you have a couple other examples there of H3PO4 and HNO3. Now, if we go to look, and we'll write these out, and we'll name these specifically. So if we go here, and we look at, so H3PO4, so we have H3. So again, we have our anion right here. So being PO4. For those of you that remember from your polyatomic ion sheet, PO4 is phosphate. And we have the suffix 8 at the end there. So the big thing that we do here is we're going to change that ending to ic. And there's going to be a slightly more change in phosphate. But what that ending is going to change to, it's going to become phosphoric. And so H3PO4 being phosphoric acid. And the other example I talked about there was HNO3. Our anion being NO3, and this being nitrate. So here where we change the ending of the suffix here to ic again, so we're going to get rid of that, and it wants to become ic, so being nitric acid. Now you notice that when I'm naming these, I don't just change the ending to ic, I also end it with acid. And that's an important part when you go along with naming acids. It's just not nitric. So HNO3 is not called nitric, or H3PO4 is not called phosphoric. It's phosphoric acid or nitric acid. Now, if you also look on page 65 of your textbook, table A2.18, you'll see some more specific examples of some acids. Now, recognizing bases by their formula. So that's in a way, so the previous ways were examples that we recognized acids, now recognizing bases. So the presence of the hydroxide ion, or OH negative, with a metal ion or the ammonium ion usually indicates that a substance is a base. So example, NaOH, or sodium hydroxide, is formed when it dissolved in water. Now consider any compound with high solubility and OH on the right-hand side of the formula to be a base. Now here's a table giving you some of the common bases, and one thing you'll notice that's a lot different when we were naming acids. If we just go here, you can see if we use the example of sodium hydroxide, so NaOH, the name, again, sodium hydroxide, it's not sodium hydroxide base or sodium hydroxide basic, it's still just sodium hydroxide. So we go through the same process of naming ionic compounds. So bases still have that ionic compound name. Whereas when we were talking about acids before, yes, you were changing the end to -ic, but you were also identifying that it is an acid. Now, bases are excellent at dissolving and dislodging oil and grease, and at being an oxidizing agent, so meaning that they have the ability to break down stains in the colorless compounds. So example of this are shampoos. They are slightly acidic, however, so they do not strip out the oils in your scalp and hair. So they're basic in the fact that they're able to clean the grease and other grime that's in your hair. So if you're greasy and haven't showered for a week, or you're sick or whatever, your hair gets all greasy and stuck to your head, and not a great look. However, that'll clean your hair, the basic solution. But you want to keep that acid in there so they do not strip the oils right out. Now, when acids and bases react together, both acidic and basic properties disappear. And this is neutralization. So they don't really have a property of one or the other anymore. They're just a neutral solution. So going back to that pH scale, they're at that 7 point. Now, neutralization is a reaction between an acid and a base that produces water and a compound called salt. So example of this would be ammonia on a bee sting. You have salt and water being produced through this reaction and this neutralization reaction. And that's it for naming and identifying acids and bases. So again, just to recap, if we go back and we look here, let's just get a new so we get a new, if we have acids, so a couple things. So begin with H, end with COOH. When it comes to the name, it suffix of anion changes to -ic, and also call the compound an acid. However, with a base, it ends with OH, and you do not change the ending at all. It goes back to the basic naming properties that you would have with an ionic compound. So OH being, again, hydroxide. So that's how you name acids and bases. Hope you can take a little bit from that today, and thanks a lot.